Hey guys, so I decided to make a video that covers everything that we've done this week for our test to help you review for it if you're at home trying to study up. What I'm going to do is I'm going to go over every question that we did in class and I'm going to go over it through the different days. And I apologize if you hear the lawnmower outside, just ignore that. But yeah, we're going to start with what we covered on Monday. You'll see me go through this one note here for each day that we did each problem. So we're starting with what we did Monday with modeling with expression. So I'm doing all the notes again, if that's what you're wondering. I'm going over all the notes that we did in class again so that you can go over it with me, or you can just skip to the part of the video where you want to rewatch it. Okay? But I'm going to start here with 2.1 modeling with expressions. So all the answers are already shown here, and that's okay. But I'll just explain and talk you through it. So terms and coefficients. So for this first expression, the terms are everything. Literally everything that you see here is a term. The 2x, the 3y, the negative 5z, and the 7. And you can see that I've kind of color-coded them as well. Okay, so if you were to write the terms out, the terms would be 2x, 3y, negative 5z, and 7. Okay, the thing that most people will forget is the negative 5z. If you just write 5z, then you're doing it wrong. That is not the term. The term, because of that minus sign, the minus sign is there because that 5 is negative. So make sure you remember to put it down on your paper. Okay, negative 5z counts. So those are the terms. Everything's a term, all four of them. We're not leaving anything out. Everything's a term. Just keep in mind the negative. The coefficients, however, are a little different. Coefficients are a little bit more particular. They are just the numbers that correspond with a variable, okay? So the 2 is a coefficient because it's for the 2x. The 3 is a coefficient because it's for the 3y. And again, don't forget the negative here. Negative 5 is a coefficient for the negative 5z. It's not the whole term. It's not 2x, 3y, and negative 5z. It's just the numbers that go with those variables, okay? Just 2, just 3, and just negative 5. 7 does not count as a coefficient because it does not have a variable, okay? 7 counts as a term, it counts up there as a term, but it does not count as a coefficient because there is no variable with that 7, okay? So the next one, negative a plus 6b minus 8 plus 10c. Again, everything is a term, okay? So negative a is a term, 6b is a term, negative 8, again, be very mindful of these negatives, 10c. These are all terms, okay? So negative a, 6b, negative 8, and 10c are all terms. Everything there is a term. Just remember about the negatives, okay? The coefficients are a little more particular again, okay? So the coefficients are the numbers that go with a variable. So even though, I see my variable a, even though I don't see the number, keep in mind that negative a is the same thing as negative 1a. So therefore, the coefficient for that term is negative 1. Of course, it's pretty obvious. The coefficient for b is 6, and the coefficient for c is 10. All right, again, it's just the numbers that go with the variables. Negative 8 is not a coefficient because negative 8 does not have a variable. Negative 8 is just alone. Okay, but the main thing to point out here, the main thing to remember is not only the negatives, but negative 1 as the coefficient of negative a. Okay, so you can see I've written it down here. I've made sure to emphasize it because they are the same thing, these two. But that negative 1 kind of invisible to us unless you write it down. All right. I'm going to skip these, but it's pretty much the same thing that we've talked about. The terms are 5n, negative 2p, positive q, and negative 9. The coefficients are 5, negative 2, and 1. Again, the terms for the last one are f, negative 8g, 12, and 7h. The coefficients are 1, negative 8, and 7. Forgot to color code that 7, but it's okay. Modeling with expression. So here we're translating this expression into a statement. What's the word? What's a phrase for it? And the reason I'm doing this is to help you out with word problems in the future. So because I'm saying A represents age, when I write my expression, I'm going to say age in the expression to represent where that A belongs. Now, 3A plus 6. Here's how we're going to translate that. Because of the plus 6 there, I'm going to write 6 more than, and then it's adding 6 to 3A, so 6 more than 3 times the age. Okay, so I didn't write it. I could have written 3 times the age plus 6. Don't get me wrong. I could have done that. But I wrote it this way because we're going to see it written that way in a lot of the other problems. And I want you to remember that even though it's written that way, it's still technically 3A plus 6. Okay, 6 plus 3A is still the same thing, but you're going to know why I'm doing this for the second example. The second example, 2A minus 5. Since we're subtracting 5, it's going to be written as 5 less than. We're subtracting 5 from 2A. So 5 less than 2 times A, which in this case will be twice the age. 2 times A is twice the age. You're doubling the age, it's twice the age. Okay, remember A represents age. So in our word problems, they're going to be worded this way, which is why I've done it and went ahead and wrote them down that way. What I want you to really pay attention to is the fact that the plus 6 and the minus 5, they come second in the expression. They're not written first. The plus 6 is after the 3A, the minus 5 is after the 2A. But I wrote them down first, and we're going to read them first as well in future statements and future problems. I just want you to remember that when you see it written that way, the 6 more than, the 5 less than, that plus 6 comes after the 3 times the age, and the subtracting 5 comes after the 2 times the age. That even though they're written first here, you kind of have to remember that flip-flop nature of it, the fact that it's going to be second in your expression. So just do that for me and we'll be good. All right, now the third and fourth one are a little different. We're not talking about age anymore, but I am going to kind of help you understand how they're going to word this in a problem. So we have 4 times x plus 2, but I'm not going to just write 4 times x plus 2. Because if I did, I would be saying 4 times x plus 2, and it doesn't really indicate the fact that they're parentheses for this problem. So here's how we're going to say it. We're going to say it as 4 times the sum of a number and 2. Now, when I say 4 times the sum of a number and 2, that is me saying x plus 2, but as a group in parentheses. And that is being multiplied times 4. So when I see those parentheses, I'm thinking 4 times the sum of a number and 2. Okay, now the last one's got a minus sign. So the last one is similar to it, but it's for subtraction. So it's going to be 3 times. It's not 3 times x minus 6. It's 3 times the difference of a number and 6. Okay? So just be very mindful of those statements, okay? Be very mindful of all of that. Okay, and this is the last thing from Monday. Write an expression for each statement. So it's the same thing we just talked about, but the reverse order of it. So this is where it's important, because in word problems, this is how it's going to be phrased, and you've got to make sure that you can write down the right expression for it. So 5 more than 3 times her age. Because that 5 more than is there, it means we're adding 5 after it. So this will be 3a plus 5. 3 times the age plus 5. Remember that flip-flopped nature of it. Even though it says 5 more than, I'm actually writing 5 second here. Okay. Same thing with the second one. 6 less than twice her age. So we're subtracting 6 from twice her age. So it'll be twice the age minus 6. Here's the real reason why this matters so much. Because even if you read it and you write it as you read it, 6, and you think less than means minus twice her age, you have to understand that this is not the same thing as what we have here. Okay? Subtraction, it matters. It matters a whole lot where that 6 goes. So for all of these, I just want you to get in the habit of doing that flip-flop, reversing the order. 5 more than 6 less than, that means adding 5 and subtracting 6, but do them after you write the 3a and the 2a. Write them second in the expression. So the last two, 4 times the sum of a number and 5. So we're going to have 4 times parentheses the sum of a number and 5. So x plus 5. Sum means adding. And the last one, 6 times the difference. So again, parentheses. Difference means subtraction. So it'd be subtraction, a number and 1. So x minus 1. So there's your expressions. All right, I'm going to keep the video going instead of pausing it and making a new one. I'm going to go to October 1st, and I'm going to do the notes that we did October 1st with you here as well. So now we're writing equations as statements. Now, this is very similar to what we were just doing, except we have the equal sign, so that's important to pay attention to. How we're going to write the statement out for n plus 7 equals 13 is like this. N plus 7 equals 13 is going to be 7. Oops. You can write out 7. You can just use the word 7. I'll just use 7. 7 more than a number. So this is saying x plus 7. 7 more than x, 7 more than a number, or 7 more than n, is 13. So the is your equal sign. Okay, that's mainly the big difference between this and what we were just doing. Now for the second one, remember I see that minus 1 second, but I start with that in my statement. Because it's minus 1, it means 1 less than 2 times a number. So you can say twice a number or 2 times a number. 1 less than twice a number is 7. So remember that flip-flop nature of it. I'm doing that here as well. And I'm going to do it in that last one. So 4n plus 9. That's 9 more than 4 times a number is 21, since it equals 21. So notice, I started with 7 more than, 1 less than, 9 more than. That's the second part of the expression here. So just remember that flip-flop nature of these problems, okay? This right here is the same idea, but the opposite. This is where it matters because this is what you're going to read in your problems, and I want to make sure that you can write the proper equation for it. So 6 more than a number is 8. So that is saying that a number plus 6 equals 8. You can say x plus 6 if you want. I'm going to say n plus 6 just because we saw n on the previous ones. 9 less than twice a number is 10. So 9 less than, remember, that comes second. Don't get tempted to write 9 minus right away. Remember the flip-flop nature, okay? 9 less than twice a number. So 2 times a number, and then minus 9 equals 10. Same thing on the last one. 11 more than, we're going to be adding 11 after, okay? Second, 5 times a number. So 5 times n plus 11 equals 31. Remember, 6 more than, 9 less than, 11 more than. I did not write these first. I wrote them second, okay? The flip-flop nature. Again, keep that in mind. Now we're going to solve for a variable. So these are unique in the sense that we don't have any numbers here. All we're trying to do is isolate a letter. So this first one says solve for b. So that means we need to get this b here by itself. To do that, I have to somehow cancel out mx. Now, since mx is together as a term, I can actually get rid of them both at the same time. I can get rid of them both together. Now, since b is being added to mx, mx is positive, I'm going to subtract mx. Okay, I'm subtracting because of it being added with b. So subtracting mx, right? I'm going to be canceling that out on the right-hand side. So the b is all that's left on the right-hand side because mx is going to cancel out. On the left, though, I can't combine these because there's not numbers. I just have to write it all out. It's y minus mx. And that is your answer. y minus mx equals b, or you can say b equals y minus mx. B is by itself. That is it. That is the answer. You're done with that problem. Let's look at c equals 2 pi r. Here we're going to solve for r. Now to solve for r, we need to get rid of 2 pi. We need to cancel that out. Again, 2 pi is together, so we can get rid of them together. But how? Well, since 2 pi is getting multiplied to r, right? It's 2 pi times r. Then we're going to divide by 2 pi in order to cancel it out. So notice the difference between this and the last problem. Mx on the last problem we subtracted because we were adding it to b. 2 pi, we're dividing it because it's getting multiplied to r. They're very similar, but also very, very different. So we have the r by itself because the 2 pi cancels, and on the left we just have c divided by 2 pi. We can't do anything about that. We can't put them together. Just c divided by 2 pi. That's your answer for r. For the next one, we have solving for h. We have v equals LWH. This is almost identical to the C2 pi r problem because we're solving for h, and h is getting multiplied with LW. So in order to cancel out LW, since it's being multiplied to h, I'm going to divide LW. Just like, over there, I divided by 2 pi because it was being multiplied to r. Here I'm dividing by LW because it's being multiplied to h. So dividing by LW, that's going to all cancel out. So h is by itself. And on the left-hand side, we just have, v divided by LW. So there's your answer. And then one more. We have to solve for m. D equals m over v. So to get m by itself, I need to be able to cancel out v. Now notice, v is in the denominator. That means that it's m divided by v. So we have to undo that. The opposite of dividing by v would be to multiply by v. That is how you'll cancel out that v. So we do that on both sides, just like everything else in the problem I've done on both sides. I divided 2 pi on both sides. I subtracted mx on both sides. I divided LW on both sides. Here, if I'm multiplying by v to cancel it, I have to multiply v on both sides. So that cancels the v out. So m is by itself, and m is equal to v times d. And that's it. That is your answer. All right. Just for the sake of time, I'm going to skip these. I'll work them out, but I won't necessarily explain them just because of time. I want to make sure that I focus on teaching everything. But here, we're solving for m. Y equals mx plus b. But we're solving for m. So we're going to cancel out b. That gives y minus b equal to mx. And then because we're solving for m, I got to cancel out x being multiplied. So I'm going to divide by x to cancel that out. So m is equal to y minus b divided by x. Now for the next one, v equals LWH. It's pretty much the same thing. We're solving for w, so to cancel out L and H, we're just going to divide L and H because they're both getting multiplied to w. So dividing them cancels them out. We have w by itself, and v is equal to L times h, or v divided by L times h. And then the last one is kind of a tricky one. D equals m over v. But again, we're solving for v here. So we have to cancel out m. But here's the problem. We can't cancel out m and leave v in the denominator. So what we're really going to do is we're actually going to move the v to the other side. So that means we have to cancel the v out on this side, the right side, so that I can move the v to the left. What that does, right, we have the equation we had from the last problem up there. What that does is now the v is not in the denominator. I have to make sure that the v is not in the denominator. So I multiplied v because that side has dividing by v, and it cancels out v on the right. But it just relocates the v to the left-hand side where it's no longer in the denominator. Now I can actually solve for v. Now, since v is not in the denominator, all I got to do is cancel out d. And I got to cancel that out by dividing by d. And we have, at the end of this, v equals to m divided by d. All right, 2.4, write each inequality as a statement. So it's very similar to how we started this section of our notes on Tuesday. with the equations. Okay, but again, remember the flip-flop nature of writing these out. So this is 3 more than a number, adding 3, n plus 3. So it's 3 more than a number. Now, it's less than or equal to 10, but I'm not going to write less than or equal to 10. Instead, I'm saying because it's less than or equal to 10, that n plus 3 is at most 10. When I say at most, it means that it can be 10 at most, which means it can be less than 10 or 10 as a max. It can't be past 10. 10 is the cap. 10 is the most it could be, but then it's also less than 10. Okay? So if I said, like, hey, the Bucks or the Rays, let's say the Rays, right? The Rays scored at most 10 runs. Then they didn't score 10. They didn't score more than 10. They scored 10 or they scored fewer than 10, which is what we're saying here. Less than or equal to 10. So when I see less than or equal to, think at most. Now, similar train of thought, let's look at the next one, right? The next one we have subtracting 1, so it's 1 less than 3 times a number. So that's not going to be new to us. We've been doing this already. Subtracting 1, we're doing 1 less than 3 times a number, but it's greater than or equal to 17. So what we're going to say is if it's greater than or equal to 17, that it is at least 17. If I say the Rays scored at least 17 runs, then they scored 17 runs or more than that, right? So greater than or equal to 17 runs. So that's why we're using the phrase at least. At least implies that 17 is the bottom of the barrel here, and you're scoring that 17 or more. And the last one is 2 times a number is less than or equal to 22, so is at most 22. Oh, I forgot to mention it, but greater than or equal to was our at least. Try to remember that for our test on Thursday. Now, here's where it really matters, okay? We have to take this and write the inequality for it. So make sure that you can write the inequality. A number increased by 8, so n plus 8 is at most 14. So it is less than or equal to 14. Remember, at most, less than or equal to, right? 9 more than twice a number, so twice a number plus 9, is at least 31. So it's greater than or equal to 31. It's 31 or higher. So it's bigger than or equal to 31. And then the last one, 6 times a number is at most 30. So it is less than or equal to 30. Okay, that covers everything from Tuesday. Now let's talk about today's, right? Wednesday. So here we're solving the inequalities. So when we solve these, right, we actually have to do quite a bit of the math here. Okay, we're getting a little lag, but we're all set. All right, we're solving and graphing. So x plus 8 is less than or equal to 19. So I'm solving this. I need to get the x by itself. I'm not trying to write out the statement for it. Okay, I'm actually solving this, getting my answer here. So I need to cancel out plus 8 in order to get the x by itself. So to cancel out plus 8, I subtract 8. That cancels it out, and now the x is by itself. The inequality sign stays the same. It's still less than or equal to. And then 19 minus 8 simplifies. 19 minus 8 is 11. So x is less than or equal to 11. Now, when you graph this, we need to make sure that 11 is on our number line. And because it has a line underneath it, right? It's got the little equal to line. It's got the line underneath the inequality symbol. If it has a line under it, that's going to be a shaded circle at that value. As opposed to if it doesn't have a line under it, it'll just be an open circle. So like a regular less than sign or a regular greater than sign would have an open circle where the one with a line under it has a closed circle. So since this has a line under it, it's going to be a closed circle at 11. And we're saying x is less than 11. So if it's smaller than 11, then it's over here. 10, 9, etc., all those numbers. All right, so now let's do b. We have 2d minus 1 is greater than or equal to 15. So to solve this, right, to get d by itself, I have to cancel out the minus 1, and I have to cancel out the 2. So we're going to start with the minus 1. We're going to cancel that out by adding 1. Adding 1 will cancel out the minus 1. So we have 2d is greater than or equal to 15 plus 1, which makes 16. And now I got to cancel out the 2. Since 2 is getting multiplied with d, I will divide by 2. That'll cancel that out. So we'll have d is greater than or equal to 16 divided by 2, which is 8. So when I graph this, 6, 7, 8, 9, 10. When I graph this, because I've got the line under it, it's greater than or equal to. That's going to be a closed circle for 8. But remember, d is bigger than 8. So if it's bigger than 8, that's 9, that's 10. That's the right side of the number line. And there's our answer. There's our shaded answer. And our last one, 3 times a plus 4 is less than 15. So here's the problem here, right? I've got the parentheses. Let's deal with this first. To get rid of those parentheses, we need to distribute, all right? Or that means multiply 3 to the a and the 4. So to the a first, 3 times a is 3a. 3 times 4 is 12. So it's all I've done was multiply the 3 to both of those terms inside the parentheses. 3 times a converts that into 3a, and 3 times 4 converts it into 12. So now there's no more parentheses. Okay, it's just the regular numbers. So we're solving it basically now just like we solved this last problem, right? We got to cancel out the 12, and we got to cancel out the 3 here. So the opposite of plus 12 is minus 12. So we'll subtract it, and that'll cancel out 12. So we have 3a is less than 3. 15 minus 12 makes 3. Now I got to cancel out the 3, the one here, the one that's on a. To cancel that one out, because it's getting multiplied to a, I will divide by itself. Divide that by 3 so that 3 can cancel out. But of course, don't forget, you got to do it to both sides. So a is less than, well, 3 divided by 3. 3 divided by 3 is 1. So a is less than 1. So when you graph this, have a number line, -1, 0, 1, 2, 3. Because there's no line under this inequality sign, that means it's an open circle at 1. And then remember, a is smaller than 1. A is less than 1. So 0, -1. These numbers here, the left side is less than 1. So we're shading that side in. All right. Now, these compound inequalities. We have 2 types of compound inequalities. We have ands and we have ors. And inequalities and or inequalities. Now, A is an and inequality. Okay, you can always tell an and inequality when you have x in between 2 numbers, or any letter you want, any variable you want in between 2 numbers. Now, all we're going to do here is graph it. We're not actually solving anything, we're just graphing. So make sure my number line, because we're going from 2 to 7, has to be at least big enough to have 2 and 7 on it. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I usually like to make sure that I have enough room for the 2 and 7 with a little extra space on the left or the right hand side, just as like a little bit of a buffer. So when I look at this, I see x is less, or 2 is less than x, right? This is saying here that x is bigger than 2. First, it's an open circle at 2 because there's no line underneath that symbol. So it's an open circle at 2. But it's also saying that x is bigger than 2. So that would be shading that direction, to the right. Look at the other part of this inequality. X is less than or equal to 7. So first and foremost, it's got a line under it, so we are shading that in at 7. But remember, it's saying x is smaller than 7. X is the number that's smaller than 7, so that would be shading towards the left. Now, if I'm combining the shadings, I'm shading to the right of 2 and to the left of 7, which means I'm shading in between 2 and 7. And so that shading is very representative of our inequality. This says x is between 2 and 7. So guess what? When we're shading between 2 and 7. All and problems are going to be shaded like that, where they're shading in the middle or in between. So B is also an and problem, okay, because we got x in between. So I'm going to expect that my shading will look something similar to that first one, where I'm shading in between numbers. So -5, -4, -3, -2, -1, 0, 1, 2. So first and foremost, if I'm looking at -4, because it's got a line under it here, I'm going to have a closed circle at -4. All right, I'm also going to have a closed circle at +1 because I've got that inequality symbol with the line underneath it at that 1. So what we're saying here is x is between -4 and 1, right? And I shaded in both those circles. So we're shading in both the circles, but we're also shading in between -4 and 1. X is between -4 and 1, so we're shading between -4 and 1. So that's what our answer will look like. Now let's look at C. Now C is an OR problem. It's pretty obvious. It says OR on it. Let's see how these are different from the AND. So I need my number line -2 and 3. So let's have -3, -2, -1, 0, 1, 2, 3, 4. That's good. Okay, so one thing at a time. A is less than or equal to -2. So we're going to have a closed circle at -2 because it's got the little line underneath the inequality sign. But A is less than -2. A is smaller than -2. -3, -4, the numbers here on the left are smaller, so we're shading it into the left-hand side. Okay? All the numbers in this region are smaller than -2, which is why we're shading on that region. Let's look at the other inequality. A is bigger than 3. Now, that doesn't have a line under it, so we're actually going to leave an open circle there for at 3. But now it's A is bigger than 3. So we have to shade in all the numbers that are bigger than 3. That would be 4, 5, 6. That'd be everything on the right-hand side of this number line. And that is your graph for C. So notice the difference. An AND graph is shading in between. Okay? An OR graph is shading opposite directions. They're going opposite ways. And that's always going to be like that. And graphs will always be shaded in the middle, or graphs will always be shaded opposites. Okay? Now we have one more to do. We have that last one. We have A is greater than, or A is less than or equal to 3. So less than or equal to 3 means it's going to have a closed circle at 3. And then less than 3 is to the left. 2, 1, all those numbers are less than 3. A is greater than 6, open circle at 6, and greater than 6 is 7 and 8 and 9, all those. It is another OR problem, right? So we should be shading opposite ways, and you can see that we are shading opposite ways. They do not shade in the middle. They do not meet in the middle. They go opposite directions. All the ORs will go opposite direction. All the ANDs will go in the middle, okay? All right, and we have just a few more problems to work out. This is the last few problems. So we are solving these compound inequalities. Okay, we are going to solve them and we're going to graph them. So our first one, we have -a plus 5 is greater than or equal to 12, or we have -5a is less than or equal to 25. Now it's an OR problem. Okay, so I know that when I graph it, my number line, my shading will go opposite ways. Every OR problem shades opposite directions. So we'll see that when we graph it later on. But we can't graph it until we solve it. So we got to solve this first. So there are two inequalities here. And what we're going to do is just solve them separately. Solve them one at a time. So I'm going to focus on the one on the left side first. So I need to get this a by itself. That means canceling out the 5 and canceling out that negative. So to cancel out the 5, I need to subtract 5. Because the opposite of plus 5 is minus 5. So I'll have -a is greater than or equal to 12 minus 5, which is 7. But now I have to cancel out this negative. Here's something that we talked about very beginning of this video, and I'm actually going to go ahead and show you, right? That negative a, if I go back to September 30th, right? My notes for the coefficients. Remember, negative a is the same thing as negative 1a. There's a negative 1 hiding here. That 1, you don't see it originally, but it is technically there. So when I see this negative a in my problem, I'm thinking really that it's negative 1a. Now, why am I showing you that? Because that helps me get rid of that number. I need to cancel out negative 1. Since negative 1 is being multiplied with a, I would divide by negative 1 just to cancel that negative out. So now the a is by itself. However, because I'm dividing by a negative, right? I need to flip my sign. Okay, I'm dividing by a negative number. I'm dividing by negative 1. And when that happens, my sign has to flip. So it'll be less than or equal to negative 7. 7 divided by negative 1 makes negative 7. Okay, now on the right-hand side, we have pretty much the same thing. We have to get rid of negative 5. So we have to divide by negative 5 because it's getting multiplied with a. So a is positive now. However, again, divide by a negative, so we need to flip our sign. Okay, the sign's going to be flipped over. It's going to be greater than or equal to now. 25 divided by negative 5 is negative 5. So there's your answer. This or that. And then when you graph it, we'll have, see, negative 9, negative 8, negative 7, negative 6. Oops. Negative 5, negative 4, negative 3, negative 2. Right? It's an or, so we're graphing outwards. So we have a closed circle at negative 7, and we're shading to the left because it's smaller than negative 7. And then we have another closed circle at negative 5, and we're shading outwards. So we're going bigger than negative 5. There's our answer. There's our graph. Let's do B. B, we have negative 3. Oops. Negative 3 less than 2a minus 1 less than or equal to 9. Now this is an and problem. So how we approach this is we have to try and focus on getting a completely by itself, but in the middle. Okay? So that means canceling out the minus 1, canceling out the 2, because without those, then the a can be by itself in the middle. So we're always going to start with that minus 1 here. So we're going to add 1 to the middle so that we can cancel that out. But we have to add 1 on all the sides as well. So what that leaves us is it leaves us negative 2 on the left-hand side, leaves us 2a in the middle, and leaves us 10 on the right. So I've canceled out the 1. Now I got to cancel out the 2. So since it's 2 times a, I will divide by 2 to cancel that out. But of course, just like with the 1, I have to do the 2 on all sides. So negative 2 divided by 2 is negative 1. A is all by itself in the middle. And 10 divided by 2 makes 5. Now keep in mind, I do not need to flip the sign here because I'm not dividing by a negative. The 2 I divided was positive. If you're wondering, yes, that 2 here was negative, but that's not the negative I'm worried about. It's whether I'm dividing by a negative. And I'm not. I'm dividing by a positive 2. So there's no need to flip any signs here. Okay, that is our answer. And when we graph it, we have a number line, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. I'm graphing between negative 1 and 5. Open circle at negative 1. Oops, wrong one. Open circle at negative 1. Close circle at 5. And we're shading in between. It's bigger than negative 1. And it's less than 5. So it is shaded in between negative 1 and 5. Now, let's focus on the third one, C. We have 2x plus 5 is less than or equal to 13, or x plus 4 is greater than 16. So when we do this, it's an or. So again, our graph will look something similar to this one up here, the fact that they go opposite directions. All right, but let's solve this. We got to solve this first. So to get that x by itself, I got to cancel out the 2 and the 5. So we're going to cancel out that 5 first. So subtract 5. So we have 2x is less than or equal to 13 minus 5, which makes 8. And then because it's 2 times x, we'll cancel out the 2 by dividing by 2. So x is less than or equal to 4. And on the second one, all we got to do is cancel out the plus 4. So subtract 4 cancels it out. And we'll have x is greater than 16 minus 4, which is 12. So that one really didn't take too long. When we graph it, okay, see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so we have a closed circle at 4, and we're less than 4, so it's outside again, to the left-hand side. And for 12, I have an open circle at 12, and it's bigger than 12, so we're shading to the right-hand side. Again, you can see as an OR problem, we're shading opposite directions. It's going to happen with every OR problem. Keep that in mind. We have one more to do, and that's another and. Let me write it down here. I'm just going to do it in this space. So 4 is less than 3a plus 1, less than or equal to 13. All right, so remember, our goal is get a by itself in that middle. So we need to get rid of the 1, and we need to get rid of the 3. We're going to start by getting rid of the 1. Subtracting 1, we'll cancel it out, and we'll simplify. 4 minus 1 is 3. We'll be with 3a in the middle, because the 1's gone. Just bring the 3a down. 13 minus 1 is 12. Okay, so I got rid of the 1. Now I got to get rid of that 3. Since it's 3 times a, we can get rid of it by dividing by 3. That'll cancel it out, but of course, do it everywhere else. So 3 divided by 3 turns into 1. And that just leaves us a in the middle. And 12 divided by 3 turns into 4. So when we graph it, we'll have 0, 1, 2, 3, 4, 5, 6, 7, however, whatever you need there. We have an open circle at 1. We have a closed circle at 4. And then a is between 1 and 4. So we are shading between 1 and 4. And that is it. That is everything that you will need for the test tomorrow. I hope you do well. I'm sending this video to you right now. I'm hoping that you get it because I hope you can study for it. I will see you guys tomorrow. Good luck on your test. Bye.